I don't remember doing these problems. Sine cube x into cos square x dx. Did we? We did till example 5, no? So we didn't do this problem, sine cube x into cos square x. Shall we start with this? Try to reduce. Now is it better? Or is it too much bright? Is it okay? 100% This is okay, right? Okay. So integral of sine cube x into cos square x. How to even do it? See, I'll just, before that, we will recollect certain ideas. Okay. So here we are going to use substitution method to solve problems. And second is, whenever you're thinking of substitution, check for the functions in such a way, which one is the derivative of other. For example, here we have a combination of sine cube x and cos square x. So we know the fact that sine and cos are derivatives of each other. Is that right? And the third logic that you need to have in your mind is, and the third, I repeat it. And the third logic you need to have in your mind is, if there is a denominator, then you should always try to eliminate the denominator. Is that right? So these are all the facts that you need to concentrate on. So this is the idea based on which you can solve any problem from integration. So this particular problem, what idea can we take? I told one should be the derivative of other. So what can we do? Sorry, cos square? So how do you want to do that? You want to write cos square x as 1 minus sine square x. Okay, I'll go with your logic. If it is sine cube x into 1 minus sine square x dx, what will you get? You will get integral of sine cube x minus sine power 5x dx. You have to take only function, you should not touch dx. You want to take sine cube x as t. Niranjan, did you understand that your method will not work? Okay. You want to take sine cube x as t. Is that right? So if I do this on differentiating both the sides, 3 sine square x into cos x dx is equal to dt. Okay. Then what do I do with this? If it is sine cube x, then it is t. Okay. Then for cos square x, where do I go? This expression has nothing related to cos square. You will get stuck again. Any other idea? So I'll be happy to try whatever method, whatever ideas you give. It will work. Which one? Sin square x into cos x, sir. After differentiating, you want to take sin cube x as t. So 3 sin square x into cos x dx is dt. Okay, what? One third of dt. Okay. What will you do? By substituting what? You'll have a combination of x and t. No? Substitute and see where will you compensate everything. Why are we even using substitution method? I want x to be replaced completely with t. No? I don't want a mix of both. What can we do? See, look at the highest power. No? Can you do something with that? Think of it. Can you do anything with that? So is there anything you can split and write? Sin square x into sin x into cos square x dx. Can I do that? If I do this, what will I get? Or what can I even do with this? Sorry? Okay, you want to combine these two and write it as sin 2x the whole square. That is there, but what will you do with sin x? Think of all the permutations, combinations. I'm trying to make you think, that's it. Try out everything. Gautam, any idea? Any idea? Let's see if anybody can from online can answer. Amrita, Hams, any idea? Only sin x, no dx. You want to take sin x as t. If I take sin x as t, what will I get? Cos x dx will be equal to dt. Okay. Integral of, you want to write this as t square into, you want to write this as t, but here you have cos square x dx and here you have cos x dx. But is that, you think if there is something that you can do?
Sir?
Tell me.
If you put cos cube x equal to t, sir.
You want to take cos cube x as t.
Yes, sir.
Okay. 1 minute, Nish, I'll come to that. Okay, this is t square into t. Into cos x dx, you will write it as dt, and there is one more cos x left out. What will you do to this cos x? dt by dx. You should not write dt by dx. Cos square x, if you write it as cos x into cos x dx, this cos x dx is what I wrote it as dt. And one more cos x is left out. That is this cos x. Any other idea? But still, if you want to proceed and do it, then this cos x, you have to write it as root of 1 minus sin square x. Yeah. You want to take sin square x as t. All permutations, combinations we are working upon. So if you take sin square x as t, what will you get? Okay, 2 sin x cos x dx is equal to dt. Then, so here you have sin cube x, which I will write it as sin x into sin square x, and this I'll leave it as cos square x dx. Okay, so you wanted to take sin square x as t. So sin x into t into what will happen to cos square x? 1 minus sin square x. Oh, sin x into cos x is dx. Okay. So you want to combine 1 sin x and cos x. Okay. Okay, you want to write this as cos x into cos x dx. Is that right? So you want to say sin x into cos x into dx is dt by 2. Okay, after that, integral of t cos x into dt by 2. This cos x, what do you want to do? Everywhere we are getting locked. So at some point you need to take a risk and proceed, no? So instead, can we do something in a simpler way itself? Which one? Okay, you want to take that and solve? You want to take sin square x into cos square x as t. That's a big thing. Because you will need to use chain rule, no? Unnecessarily you will introduce plus and all. Sin square x into cos square x, if you take it as t, then what you do? You have to do chain rule for sin square x and product rule for sin square x and cos. Why do you want to complicate unnecessarily? Simpler way. Okay, let's try this and see. Sin cube x into cos square x. Tell me, Nitish.
Sir, cos cube x equal to t wanted to x. Sir.
Cos cube x is equal to t.
Yes, sir.
Then you will have 3 cos square x into cos x. Sorry, 3 cos square x into minus sin x dx as dt. Okay. So cos square x dx will give you some relation with t, but what will you do to the sin x? Nitish, are you able to understand?
Yes, sir.
So tell me. Stuck? Okay. So can we proceed like this itself? Integral of sin x into sin square x into cos square x dx. So what shall we do? We'll take sin x as t and then proceed. Okay. Sin x as t, then cos x dx should be equal to dt. So integral of, you just need to do some manipulations and then proceed. So sin x t into sin square x is t square into this cos square x, I can write it as cos x into cos x. Can I do that? Right? Cos x into, and you have this dx. But what is cos x into dx? Here also you have cos x into dx, which will be dt. So integral of t cube into, what can I do to this cos x? Yeah, 1 minus t. Root of 1 minus t square. Root of 1 minus t square. Okay. And this will be dt. Okay. So integral of t cube into root of 1 minus t square dt. How to even proceed from here? So this problem we need to go with double substitution. So I told you about problems. I told you, whenever problems have square root, what are you supposed to do to the square root? Eliminate the square root. So 1 minus t square, I can take it as 1 minus t square, we'll take it as something else. Tell me. So 1 minus t square, can I take it as y square? Why did I take y square?
And only
I have
root.
that square, so that it will get eliminated is what a trial that I'm trying to do. So 1 minus t square is y square, means minus 2t into dt is equal to 2y into dy. Am I clear with this point? Is it clear, guys? Right. So integral of t cube, what can I do? T cube, I can write it as t square into t into root of 1 minus t square. As of now, I'm leaving it as it is, times dt. Now observe, what is t dt? What is t dt? Concentrate. So t dt is minus y dy. Makes sense? So integral of, in the place of t square, what can I do? I'll come in the order. In the place of t square, what can I write it as? Very good. 1 minus y square into, in the place of t dt, I can write it as minus y dy into, in the place of root of 1 minus t square, I can write it as y. 1 minus t square is y square. Root of 1 minus t square on the y. Be careful, okay? Is everyone able to understand? Is everyone able to understand the logic? Yes? Page template learn. Okay. I'll borrow some space from here. Now, is it not easy for you to do? Minus, if you take out, you will have y square minus y power 4 dy. Now, can you integrate to this? Can you? So, what is integral of y square? Y cube by 3. So, this will be minus y cube by 3, and this will be plus y power 5 by 5 plus c. But what is y? Y is root of 1 minus t square. So minus 1 by 3 into 1 minus t square under a root will be 1 minus t square the whole power 3 by 2 plus 1 by 5 into 1 minus t square the whole power 5 by 2 plus c. Am I right? But what is t? T cos a sin ada. Sin. So t is sin means 1 minus 1 by 3 into. See, I am doing it in mind itself. That's what I'm saying. I asked what is t. Yeah, that's what I. So t is sin x. 1 minus sin square x is cos square x. Cos square x the whole power 3 by 2 is cos cube x plus 1 by 5 into 1 minus t square is cos square x. Cos square x the whole power 5 by 2 is cos power 5x plus c. So answer will be minus cos cube x divided by 3 plus cos power 5x divided by 5 plus c. Please check if it is matching with the textbook. Sometimes it might not match because it is a problem based on trigonometry. Answer match or that's our luck. Yeah, no, first I did so many times. Suddenly you're asking, which step is your doubt? So such a big problem. Which step is your doubt? Sir, from the t cos x dt. Either. Idua. This thing, huh? Yes, sir. Yes, sir. T cos x dt by 2. Did you write down the problem? Okay. Okay, see, the sin cube x, I broke it as sin x into sin square x. Everybody concentrate. Okay, is that step clear? Right, in the place of sin x, I substituted, replace sin x with t. Differentiated on both the sides. Cos x dx is dt. Okay, so in the place of sin x, I wrote it as dt. In the place of sin square x, I wrote it as t square. So in the place of cos square x, I broke it as cos x into cos x. And what is left out? Dx. Is that point clear? But when you differentiated the sin x as t, you got cos x dx as dt. Appa cos x dx vandu, see, this cos x dx, I replaced with dt here, right? This t into t square, I got t cube. This cos x, what will happen? So if sin x is t, if sin x is t, then what is cos x? Root of 1 minus t square. You know this, right? Yes. So it is root of 1 minus t square. But the problem is whenever you have in an algebraic expression, whenever you have square root of something, you cannot integrate. So you need to eliminate the square root. For that square root only what I did is I took the value inside the square root as y square. Okay. Then I differentiated on both the sides and proceeded. Minus 2t dt is equal to 2y dy. Then this t cube, again I wrote it as t square into t. Okay. T square into t into root of 1 minus y square dt. So this t square is what? See, 1 minus t square is y square. Then what is t square? 1 minus y square. That is what I substituted here. Okay. Root of 1 minus t square will, sorry, t dt combined together from this step will be what? T dt combined together will be minus y dy into root of 1 minus t square is y. Then what I did is combined everything and then I did the normal integration. Again, in the place of y, I substituted 1 minus t square under a root. Okay, root of 1 minus t square. And in the place of t, I substituted sin x. So since we did double substitution, we need to substitute the values 2 times back. And we got the final expression as this. Is that clear? So mark it as important. Try it again. Shall I proceed? See, this one is also slightly complicated, okay? So I gave you 3 important steps, right? Whenever you are integrating, what are the 3 steps I told you? You wrote it. What is it? First is substitute. Second, eliminate the denominator. So there is a problem with denominator. My job is to eliminate it. Okay, but how do I do? If I expand sin x plus a, that is in the denominator, I have no advantage out of it. Why? Because if I expand it, I'll get sin x cos a plus cos x sin a. Had it been by sin x, then it makes sense because by sin x will eliminate. Then what would have happened? I would have got cos a plus cos x. Sorry. Cos a plus cos x. Is that right? No, sin x. Oh, cos a was it? Cos x sin a. Then it will be cot x sin a. Okay. See, had this been the scenario, we are in advantage. But unfortunately, that's not the scenario. It is exactly the reciprocal of it. So we need to do some manipulation to the numerator so that it becomes similar to a denominator. Listen to this, the very, very, very important idea. Why do you want to multiply? Instead, in the place of x, can I add an a and subtract an a? Isn't it easy? So that this x plus a, I'll take it as capital A, and the small a, I will take it as b. Then what will happen? Then it become integral of sin a cos b minus cos a sin b divided by sin of x plus a dx. Is the problem solved? Now split the sin of x plus a to each term. What will happen? Integral of cos a minus cot of x plus a sin a dx. Right? So it will become integral of cos a dx minus integral of cot of x plus a sin a dx. So what is integral of cos a dx? Integral of cos sin a verb. It will not come. What did I tell you? Hey, it is not cos x dx, it is cos a dx. A is a constant. It will come out of the integral. Don't get confused. So cos a into integral of dx minus what will come out of the integral in the second term? Guys, is it tough? Is it tough or what? Is it confusing? No. Little bit. It will be, because differentiation and integration are very close, but this exercise is very important. Idilana, you cannot solve the whole of integrals. So concentrate, whatever is your doubt, get it clear. But I want you all to concentrate and do it. And don't ask me at the end. At every step I'm asking. If it is clear, let me know. Breathe on. Last I get a therapy. Concentrate here. First observe. One step on extricate it. If it's clear, say clear, or else I'll proceed. Clear? So cos A into integral of dx. What is the integral of dx? Extra. Minus sin A into integral of cot n. Log of textbook worth. You can have your textbook now, so that at least you'll understand the formula. You don't have textbook. No? Can you get it? Everybody have your textbook in front of you. At least then the formula will get registered in your mind. So what is integral of cot x bar? It will not be there under it will be before 7.2. Log of something. What is it? Log of this log sin x plus. Okay. So it will become log of sine of mod x plus a plus c. So this should be the final answer. X cos a minus sine a into log of sine of mod x plus a plus c. So what? As long as the coefficient of x plus a, as long as the coefficient of x is not equal to 0, it's fine. See, it's simple, Ra. Simple. You want to take x plus a as t, nothing. X plus a, if you want to take it as t, then dx will be equal to dt. Accepted? So what will happen? Integral of cot of x plus a, can I write it as cot t dt? Integral of cot is what? Log sine t plus c. But what is t? X plus a. So whenever the power of x is 1 and the coefficient of x is 1, don't overthink. X can be added to any constant you want. Is that clear? Logic. So he was asking me if this x plus a comes, will it not become chain rule? First point to remember, chain rule is not there in integrals. Okay, there is only product rule, which is also called as by parts. As of now, we have not seen, so forget about it. So in this exercise, there are certain important takeaways. One is something like this. If you have a linear expression, which is an argument, which is an angle of a trigonometric function, you can just integrate it blindly. For example, integral of sine of x plus a with respect to x. What is it? Integral of sine is minus cos of the same x plus a plus c. You need not worry about it. Just do it. Is it clear? So is the answer matching? X cos a minus sine a into log of sine x plus a plus c.
Sir?
Yeah.
So the integration of cot x plus a dx is log sine t. How is that, sir?
That's the formula. So integral of cot x, I showed you the derivation also. Integral of cos is cos divided by sine. So put sine x is equal to t. Then cos x dx will be dt. So dt divided by t's integral is what? Log sine t.
Log t.
Okay. I saw that answer. Oh yeah. No problem. But still it is right only. So x cos a minus sine a into log of sine x plus t. Is it clear? If anybody wants to copy this, copy it. What did they do in the textbook? They would have multiplied and divided with sine a minus b, something like that. What did they do? Okay. The numerator, in the place of x, they wrote it as t. T minus A. It's the same thing. But what is the final answer, Sunu? X cos X cos A plus A cos A. A cos A. A cos A is a constant. The constant X cos A minus sin A into log of sin X plus A. That's the answer. Correct now. A cos A is a constant which will be added to C. Okay, 3 marks maximum. Shall I proceed? Again, there is another problem with denominator. Eliminate it. Even if it is wrong, right? I'm telling you, even if it is wrong, try out all the possibilities. Only then your brain will get open. So by looking at this problem, what idea you get? I told you one thing in integrals, you need to eliminate the denominator. How you are going to do it, that is in your hands. How shall we do it? So wherever I see tan x, something comes to my mind. So tan x, what can you write it as? Sin x by cos x. Do that and proceed. Try it and see. Try it. Try it. So integral of 1 divided by 1 plus proceed. Proceed. Up it. Put the whole line. Don't look at the solution, it is confusing. Added something and subtracted. Then they wanted to write this cos x plus sin x. So they added sin x and subtracted sin x. Okay. You think of what best you can do. What best can you do to eliminate the denominator? See, I'll share an idea here. Observe. See, generally, whenever you have sum of sine and cos, there are different kinds of formats that you can observe. One is, if I say a cos x plus b sin x, you suppose this of the form, then the different kinds of pattern that you can find is cos x plus sin x. So same is the case with minus also. So cos x plus sin x you will find, or you will find root 3 cos x plus sin x, or you will find cos x plus root 3 sin x. These are all some standard forms. Why they give it in this form is because this a cos x plus b sin x can always be simplified and written as a single trigonometric function. But how? Because if you look at the trigonometric tables, right? If you look at the trigonometric table, right, what are all the different angles you'll find? So 0, 30, 45, for all those things, what are the numerators? Sine 0, sine 30, 1 by 2, sine 45, 1 by root 2, sine 60, root 3 by 2, and sine 90 is again 1. So what are the two numbers that you are able to see regularly? Keep the 0 aside. 1 and root 3. That is right. You see the coefficients, right? If the coefficient of cos x is root 3, the coefficient of sin x will be 1. If the coefficient of cos x is 1, then the coefficient of sin x will be root 3. So in these kind of problems, what you're supposed to do is divide numerator and denominator with root of a square plus b square. This is a very important idea. Whenever you find this kind of a pattern, right? Because I'm able to find this kind of a pattern in the denominator, right? I'm able to find it in the denominator. The coefficient is 1 and 1. So if I divide with root of a square plus b square, what will I get here? What will I get this? 1 by okay, actually one more point. Multiply and divide. Multiply and divide the denominator with root of a square plus b square. So what will I get? At least right, I gave you the hint already. Coefficient of sin x and cos x is 1. So root of 1 square plus 1 square is root 2. So multiply and divide it with root 2 plus 1 by root 2 times sin x. This is point here. So 1 by root 2 into integral of cos x dx divided by this 1 by root 2. I will write it as sin pi by 4. Can I do that? I will have cos x into sin pi by 4 plus sin x into cos pi by 4. Can I do this? Okay. If I do this, observe what will happen. It will become 1 by root 2 into integral of, or else I'll do one thing. Wait. I'll write this as, I'll tell you why I'm writing in the different way. Cos x cos pi by 4 plus sin x sin pi by 4. What is this thing? The denominator, cos of or x minus pi by 4. So can I write this as cos x divided by cos of x minus pi by 4 dx? So I'll give you a minute time. Observe if there is any doubt in any of the steps, ask. Write it down. If there is any doubt, let me know. And all these problems and ideas that I'm sharing are very important. Okay. This chapter has a lot of weightage. And if your luck is bad, you'll definitely get tough problems. And tough problems can take place only with trigonometry. So concentrate, learn the ideas and implement. Engada? This 1 by root 2. Yeah. Want me to explain it? I'm saying when the coefficient of cos and sin is 1, if it is not 1 also, so in the combination around, you can either get 1 and 1 or root 3 1 or 1 root 3. I tell you. Root 2 only. Okay, that is common only. It is common to both. It is common to both. So 1 by root 2 into cos x divided by. Can anyone tell me why did I write cos pi by 4 and not sin pi by 4? Because the numerator and denominator will be the same. See, if you want, you can write it as sin also. Still, you can solve the problem, but you should get that idea. Okay. So if it is cos x divided by cos of x minus pi by 4, what I'm trying to say is I'll borrow the idea from the previous problem. What was the previous problem? Sin x divided by sin of x plus a. What did I do and what? The numerator. I added a and subtracted an a. Why did I add first and subtract second? Because the denominator was x plus a. Whereas in this problem, what am I supposed to do? First subtract and then add to compensate. So that it will become 1 by root 2 into integral of cos of x minus pi by 4 plus pi by 4 divided by cos of x minus pi by 4 dx. So this part I can take it as A, this I will take it as B. Can I do that? So cos A plus B, now apply the formula, certain things will get cancelled and then solve it. I'll give you 2 minutes time for it, do it. You should tell me. Log of secant x. Got the answer? Huh? How many of you could do it? What happened to others? You gave it till here, Noda. So 1 by root 2 into integral of cos of x minus pi by 4 plus cos. So you will have cos of x minus pi by 4, cos pi by 4 minus sin of x minus pi by 4, sin pi by 4, the whole divided by cos of x minus pi by 4 dx. Right. So 1 by root 2 into here, I'll be left out with 1 by root 2 times integral of dx minus 1 by root 2 into 1 by root 2 times integral of tan of x minus pi by 4 dx. Is this what you got? So you will get the answer as half into integral of dx is x minus half into log of secant x minus pi by 4 plus c. This is going to be the it's there, no? The textbook. Okay, it's there. So in this exercise, I have it in the beginning itself. So integral of cosecant is this thing. Integral of secant x is log of secant x plus tan x. Integral of cot x is log of sin x. Integral of tan x is log of secant x. I hope everyone is clear with this problem, right? So is this answer matching with the one given in textbook? X by 2 minus log of secant x minus pi by 2 divided by 2. Is it matching? Plus log of, because secant x is 1 by cos x. So அவன் என்ன பண்ணியிருக்கான்னா x by 2 minus half into log of cos of x minus pi by 4 power minus 1 போட்டு. This minus 1 will come here as a multiplication factor. So x by 2 plus log of cos of x minus pi by 4 plus c. This is what the answer is. Both are same. So these two are slightly tough problem, but the ideas are important. So I'll just share what they did in textbook. Okay, I'll just share the idea. I'm not going to do it completely. So what is the question? Integral of, what is it? Integral of another cos x. Integral of cos x by cos x plus sin x dx. No. So in most of the problems, if the numerator has to, if the denominator has to get eliminated, listen to this carefully. In most of the problems, if the denominator has to get eliminated, make the numerator similar to the denominator. Means cos x is there, but what is missing from the denominator in the numerator? Plus sin x is missing. So what you can do is add a sin x and subtract a sin x. When you do that, okay, cos x plus sin x. Am I clear till this step? So that what will happen is you can treat this cos x plus sin x as one term and the sin x as another term. Okay. When you do this, the advantage is integral of first term divided by cos x plus sin x will give you dx. But again, you will get stuck with sin x divided by cos x plus sin x. Okay. So for that, what they did is, if you want to eliminate the denominator, in this case, right, either on the, I will keep it as plus and this as minus. Observe, if I substitute the denominator as t, whenever you have sum of cos plus sin, if I substitute the denominator as t, what will be the numerator? If cos x plus sin x, if I substitute it as t, then what will be the numerator? That cos x minus t. That. And the dx term is differentiate on both the sides. Cos x minus sin x dx will be equal to dt. So generally when you substitute something as t, what will be the next step you will do? You will differentiate and find dx. No. So cos x minus sin x dx is dt. No? I have minus sin x here. So how much should I compensate with? I need to add a cos x and again subtract a cos x. When I do this, this whole thing can be treated as one term and this minus cos x divided by cos x plus sin x can be treated as another term. So integral of dx plus integral of cos x minus sin x divided by cos x plus sin x dx minus integral of cos x divided by cos x plus sin x dx. Am I clear till this step? Last step puriyala. Okay. So this integral of dx, I wrote it as it is. This cos x minus sin x that I combined it with the denominator and I wrote it as cos x minus sin x divided by cos x plus sin x. What is left out? Minus cos x. So minus of cos x divided by cos x plus sin x. Is it enough? So if you observe, this is what the question is. So if I say the question as I, if I take this as I, this step is also I, this step is also I, this is also I, correct? Then what is this thing? That is I. So this minus I, when it comes to the other side, what will happen to it? It will become 2I is equal to integral of dx plus integral of cos x minus sin x by cos x plus sin x dx. If 2I is this value, what will I be? Half of this. That is why they wrote that half. First step, without logic, they would have started writing it as half. But I'm saying this is how they thought. So did you get the ideas out of the problem? So important things to be kept in your mind. What did I say? Whenever you're using substitution method, especially whenever you have a fractional value, check if the numerator is exact derivative of the denominator. So for example, question one, integral of tan x dx, or I'll say integral of cot x, for example. Okay, what is integral of? So I can write this as cos x divided by sin x dx, since I don't have a direct formula. But what is the idea? Eliminate the denominator. But in this case, what is the advantage? Numerator is the exact derivative of denominator. So when that is the scenario, it is very easy for us substitute the denominator as t. Then what will happen? Cos x dx is equal to dt. Integral of this changes as dt by t. What is integral of dt by t? It is log t. That is the reason why it is log of sin x plus c. Whereas if it is sum, if the denominator is sum of something, try to check if you can write the numerator also sum and difference of something. Like how I did in that problem of sin x divided by sin of x plus a. This was there, no. What is missing in the numerator here? That is a sum that is missing. So what I did is, I wrote this as plus A and subtracted it. Idea puriyudha? Whereas in the previous problem, what do you have? You have cos x divided by cos x plus sin x dx. So what did you add and subtract? You add a sin x and then subtract the sin x, so that the numerator exactly becomes the denominator. Puriyudha? So with the same logic, I don't want you to solve the first few problems. Those are all simple. You can do it. Clearly shows you have not revised before coming. 14 வரைக்கும் முடிஞ்சிருக்கலாம். So these are all easy problems. For example, here is a good problem. Observe. So if I have this kind of a problem, I again have a fractional value. No other option. I need to eliminate the denominator. What do I do? Want to add and subtract? If that is a takeaway, let's try to do and see. So I is equal to integral of e power 2x. You want to add a 1, subtract a 1. If you subtract a 1, you will get minus 2 divided by e power 2x plus 1. Is that right? This is what you wanted to do. புரியுதாடா? என்ன பண்ணேன்னு புரியுதா? இல்லடா, I added a 1. When I subtract a 1, that minus 1 will get added to this minus 1. அதனால தான் minus 2 னு எழுதி. Okay va? Now what will happen? I is equal to this e power 2x plus 1 divided by e power 2x plus 1. It is 1. So integral of dx minus 2 into integral of dx divided by e power 2x plus 1. What will you do with this? What will you do with this? You can't do anything, because if I observe the denominator, I will always start thinking like this. If the numerator is a constant, the only option is I need to substitute the denominator as t. But I know the fact that when I differentiate an exponential function, what will I get? I'll get an exponential function. When I don't have it in the numerator, what am I going to do with it? Nothing. Okay. So this logic mostly works for algebraic and trigonometric functions. I repeated, this logic of adding and subtracting works mostly for algebraic and trigonometric functions. Whereas when you have exponential functions, observe, multiply, or I will say divide the numerator and denominator with e power x. If I do that, I'll get integral of e power 2x minus 1 divided by e power x divided by e power 2x plus 1 divided by e power x dx. So what will this become? It will become e power x minus e power minus x divided by e power x plus e power minus x dx. Did you understand what happened? Now if you observe one thing, if the denominator is t, the numerator is exactly the derivative of t, because derivative of e power x is e power x. Derivative of e power minus x is minus e power minus x. So e power x plus e power minus x, if I substitute it as t, then I'll get e power x minus e power minus x dx is equal to dt, and this becomes integral of dt divided by t log of t plus c. But what is t? So whenever you have exponential function, this approach. So now you got different perspectives. You understood how to solve. That is why I've been stressing from the beginning, eliminate the denominator. You need not think of anything. Right? So make a note of this and we'll wind up. Guys, we'll wind up. Okay. Did everyone copy? Was wrong? Did you all copy?
Yes, sir.
Yes, sir.